welcome back to my channel, Physics and Chemistry Simplified. In our subsequent lesson, we have discussed about particulate nature of matter and Dayton atomic theory and its modification. And I told us in our last class that we are going to be looking at some simple calculation under atomic structure. Let's begin today's work. Atomic structure. What do we mean by atomic structure? Atomic structure is made up of three fundamental particles, which are electron, proton, and neutron. These are the three fundamental particles that make up the atomic structure. The electron is negatively charged. Negatively charged. The proton is positively charged, while the neutron is neutral. It is neither positively charged or negatively charged. And also, based on the carbon-12 isotope, the electron has 1,840 units mass. That's their mass, based on the carbon-12 isotope. This one has 1 unit. This one also has 1 unit. Since we said the electron, proton, and neutron are the fundamental particles of the atomic structure, where are they located inside the atom? The electron is located at the orbit, or you call it shell, of an atom. The proton and the neutron, they are both located in the nucleus. In the nucleus of an atom. So let's make a simple dramatic representation of everything we have been saying this morning. We have the atom. A central place atom is known as the nucleus. This is the nucleus. The nucleus. Inside the nucleus is where we can find the proton and the neutron. Proton and the neutron. So we have the orbit, or we call it the shell. That's the shell, the first shell. We have second shell, third shell, like that. So the electron is found at the orbit or shell. Electron. So this is a typical representation of how the atomic structure looks like. The center place atom is known as the nucleus. The proton is located inside the nucleus, and the electron is located at the orbit or at the shell of an atom. The proton is always equal to the atomic number. It's always equal to the atomic number. If the proton is 11, atomic number will be what? 11. So, what do we now call atomic number now? Atomic number. So, atomic number is the number of proton in the nucleus of an atom. That's the atomic number. So the number of the proton is also referred to as the what? The atomic number. Proton number is the atomic number. There's something we call mass number. Mass number. Mass number is the number of the proton and neutron. A neutron of an atom. That is, the mass number, the symbol is A, while the atomic number, the symbol is what? C. So we can now say the mass number, which is A, is equal to what? Number of proton plus number of what? Of neutron. While the atomic number is what? Is equal to what? To the proton number. Let's do a simple calculation from here. If we are to find the atomic number, we know that we are going to add the proton number plus the neutron, plus the neutron number. So, for example, we want to find the neutron. The neutron will now be equal to the mass number minus what? Minus the proton number. So, that's just a simple calculation, quick derivatives. So in other way, we can play around with this also. We can play around with this. If I say proton also, proton is equal to what? A, this one move to this side, minus mass number minus neutron. That's the proton number. Alright. And in our last class we talked about isotope. We thought isotope has different mass number, and what causes the difference in their mass number is as a result of their what? Of their neutron. Is as a result of their neutron. And there is also a relationship between proton and electron. Proton and electron. For an atom to be neutral, the proton number must be what? Must be equal to the what? To the electron number. Proton number must be equal to the what? Electron number. That is, for an atom to be neutral, the proton number must be equal to the electron number. So that's just a simple a simple explanation or analysis about the atomic structure. So, and there are other things we can derive, but as we continue in the lesson, we are going to find out. Let's now look at some simple questions under the atomic structure. And what are these questions and how to tackle them one after the other. So let me share some questions I'm having here. Number one, an element. That's an atomic number. Atomic number of 13. And mass number of 27, if I'm right. Find the proton, neutron, and electron. Find the number of proton, neutron, and what? Electron. Solution. An element has an atomic number of 13 and mass number 27. Find the number of proton, neutron, and electron. We are looking at this question. This question has even given us an answer to a particular question, which is what? Proton. I told us proton is equal to what? Atomic number. And if atomic number is 13, if atomic number is equal to 13 and proton is equal to atomic number, therefore proton will now be equal to what? 13. So we are now left with what? With neutron and what? And electron. Let's recall the formula for mass number. Mass number is equal to what? Proton plus what? plus neutron. That's the formula for mass number. We know the proton, which is 13, but the neutron we don't know. But the mass number, we have it here, which is what? 27. The mass number is 27. The proton is 13. Why the neutron, we don't know. We want to make this neutron, the formula, this neutron to stand alone. We have neutron. This 13 is coming to this side. 27 minus 13. So 27 minus 13. That's 14, right? So the neutron is equal to 14. So by so doing, we have known the value of the what? Of the neutron. Let's now look at electron. There's a formula for calculating electron. Electron will be equal to Z. That is what's it called? Atomic number or proton number plus or minus charge. What's our atomic number? What's the question? Okay. An element has an okay. The electron. From the question, we can see that the electron is not stated. Maybe it is maybe it is a negatively charged electron. We find out that it is a neutral atom. And for a neutral atom, the proton is usually equal to the what? Is usually equal to electron. For a neutral atom, the proton is equal to the what? Electron. For an atom to be electrically neutral, the proton must be equal to the what? Must be equal to the electron. And is a neutral atom there? It was not stated. Had it been inside the question, it was stated. The atomic number is what's it called? Is 13, and we know that should be what? Aluminium, according to the periodic table. And even the question states it like this. We will have used the formula I wrote the other time. We have used the formula we wrote the other time. But because it's a neutral atom, it is what? Proton is equal to what? Electron. And what is our proton? Our proton is equal to what? 13. Therefore, electron is equal to what? Is equal to 13. And that brings us to the end of the first question. So let's move to the second one without wasting much of our time. The second question is calculate particles in a yarn. Okay, determine the number of electrons. Yes, that's the question I'm after now. Determine the number of electrons. Determine the number of electrons in calcium 2 plus. That's what I'm saying the other time. So the atomic number is what? 20. The atomic number is 20 It's a neutral atom now. The electron also should be what? 20. But it's not a neutral atom. It is what? Positively charged. And positively charged is what? Cations. And by so doing, this, I told you cation, positively charged. I told you in mathematics, plus means gain. But in chemistry, plus means what? A loss. That means this cation has what? Has lost 2 electrons. So, solution. So, we now want to calculate the electron. That's the formula I want to use the other time. We now have the Z, which is the atomic number, don't forget. Plus or minus what? Charge. So electron will now be equal to 20. Don't forget, it is what? It is cation. And the charge here is what? 2 plus. That means it has lost how many electrons? 2 electrons. So if I minus 2. So the electron will now be what? 8. As a result of losing 2 electrons, it is having what? 18 electrons left. So let's move to the second one. The third one is something like this. Second example also. But this one is referring to an anion. Find the number of electrons. Find the number of electron in, that's also given 2 minus the atomic number is 8. So it's neutral atom. They give us the neutral atom here. It's 8 also. The neutral atom is 8. But the one we ask us to find is what? Number of electron in what? In, that's what? In negatively charged atom of oxygen. Just the way we did the other time. Here, 2 minus. That means oxygen has gained how many electrons? 2 electrons. The same formula. We are applying the same formula. Electron is equal to the atomic number plus or minus charge. Then electron is equal to the atomic number is 8. And from that place, it has gained what? Because it's anion, it has gained what? 2 electrons. That's plus 2. So the electron is equal to what? 10 electrons. That's it. So we are moving to the next one, which is what? This one should be number 3. Anyway, anyhow, that's number in the way we like. The most important thing is getting the gist. Number 2. Identify an element from subatomic particles. Identify element from subatomic particles. Identify element from subatomic particles. That's the say an atom. That's how many protons do we have here? 11 protons. 12 neutrons. And 10 electrons. And 10 electrons. Okay, identify the elements. The element. B. State whether it is an ion. State whether it is an ion. Solution. So let's say identify the element from subatomic particles. What are the subatomic particles? Proton, neutron, and what? And electron. So how can you identify this element from these subatomic particles? You can only do that from proton. Proton is what? Is equal to atomic number. The proton is equal to atomic number. The proton is equal to atomic number. So that means the element in question will be the number 11 elements in the what? In the periodic table, which is what? Which is sodium. So it is sodium. We have identified the element as what? As sodium. Now let's state whether it is an ion. What do you mean it's an ion? Maybe it is negatively charged or positively charged. How do you now know if it is an ion or not? Is it that it's an ion or a neutral what? Atom. For it to be a neutral atom, that means the what? The proton and the electron must be what? Must be the same. And when we look at it very well, you see that we are having 11 proton here. And how many electrons will we have here? We are having 10 electrons. That means this particular element, sodium, has what? Has lose one what? One electron. Because for it to be what? For it to be electrically neutral, the proton must be equal to the what? To the electron. And the proton, the electron instead, proton here is what? Is 11. It's not a neutral atom. That means it's what? Is an ion. And what type of an ion? Is a positively charged what? Positively charged ion. These are just the way Neco, Waec, and Jamb set their questions. So we're just trying to do what? To look at them one after the other. Let's look at another beautiful example here. So here it talks about we have look how to calculate electron. Let's look at how to calculate charge of an electron. Let me look at the question here. And a ion has 16 proton. A ion has 16 proton. Has 16 proton. Has 16 proton and 18 electron. And 18 electron. Determine its charge. Determine its charge. There's a formula for charge. Just the way we have for electron the other time. Charge is equal to what? Proton minus electron. It's very simple to guess because we know that for a neutral atom, the proton must be equal to the what? To the electron. That means if the electron is gaining or losing, is gaining or losing a particular electron, for you now to get the charge, you have to subtract the what? The proton from the what? From the electron to get the charge. So let's now to tackle the question. And a ion has 16 proton and 18 electron. So let's calculate the charge. The proton is what? 16 minus electron 18. Mathematics now here. 16 minus 18. That will be equal to what? Minus 2. That means the charge is what? Is minus 2. The charge is minus 2. Now if they ask us to determine the element in this question, what are we going to find that out? Using the proton, which is 16 proton, which is equal to the what? Atomic number. That means the element that falls under the number 16 element in the periodic table is the element they are referring to here. And that element is what? Is carrying how many charge? Minus 2 charges. You have, so we have another question here, percentage composition. Percentage composition. I think this one should be the last, not the second two. Percentage composition also. Find the percentage of, find the percentage, find the percentage actually all this question should be copying it from my iPad, but it's not yet. Find the percentage of neutron in sodium sodium. That's the mass number of sodium. Given the atomic number is 11, and the what? And the mass number is what? Is 23. We should find the percentage composition of neutron in sodium, which mass number is what? Is 23. The first thing, they ask us to calculate the percentage of neutron. We don't even know the amount of neutron itself. Let's now look for the value of neutron first, before we even calculate the percentage of neutron in sodium itself. Our formula for mass number is equal to what? Proton plus what? Plus neutron. Our mass number 23. Our proton, which is what? Our atomic number. Don't forget. 11 plus what? Neutron. We don't know. We have done something like this. We have played around with something like this the other time. Neutron, it will now be equal to 23 minus what? Minus 11. So the neutron will be equal to what? 12. So our neutrons will now be equal to 12. So let's now calculate the percentage composition of neutron. Percent of neutron in sodium 23. Percent of neutron in sodium, in the mass number of sodium. So our sodium is what? Is 12. In what? In 23 of what? Sodium. Don't forget, the 23 has involved what? Proton plus what? Plus neutron. So we don't have anything to do with the proton again. So percentage is always what? 100 over what? 100 over 1. By multiplying. By multiplying, we should be having, let's say 52.2%. 52.2%. That is the percentage of neutron in what? In sodium. So, and the last one, yes, let's make this one the last. It's very important also. It might not really be a calculation. I might just have to what? Analyze it little by little. The other time we talk about atom. Central place atom. You have the shell. This is the first shell. You have the second shell. You also have the third shell. Like that. We can be asked that we should calculate the maximum number of electrons that we want. That will occupy the first shell, second shell, and the third shell. The maximum number of electrons that will occupy it is quite what? Is varies. And we have a formula for calculating it, which was 2n raised to power 2. We have what? N is what? The number of what? Of shell. For shell number 1. For first shell, that's the first shell. For first shell. So we're having 2. That's the 2 times shell 1. 1 times 1. 1 times 2. 2 electrons. That's the first shell. For the second shell, 2 times 2 raised to power 2. Equal to what? 2 times 2, 4 times 2, 8. 8 electrons. Just like that. Third is where I will stop. 2 times 3 raised to power 2. 3 times 3 is 9. 9 times 2, 18. 18 electron. That's why you see some electronic configuration like this. This is for aluminium. Aluminium is having how many? This is for electronic configuration. Configuration of aluminium. That's the electronic configuration of aluminium. Why is it like that? The first share, aluminum is having how many proton number? Aluminum is having proton number of aluminum is 13. So if you want to feed the electron of aluminum into its atom, the first shell is going to have what? 2 electrons. The second shell will be having 8. 1. That's 8. So, but the third shell is can accommodate 18 electrons, but aluminum is having 3 left. That means we're just going to have just feed it only. That is how it is being done. So the question can come: calculate the maximum number of electrons that will occupy the fourth shell. What are you going to do? That will be what? 2. Let's try the formula first. 2 times what? Fourth shell. You know n is the number of shell. So we now have 2 times 4 times 2. 4 is to the power 2. That's 4 times 4, right? That's 16. So 2 times 16, we have what? 32 what? Electron. So for the fourth shell, the maximum number of electrons that the fourth shell can accommodate is what? Is 32 electrons. Just like that, like that, like that. That brings us to the end of today's lesson. If you are having any other view, if you need any help in respect to calculation under atomic structure, either isotopes, calculating number, calculating charge, calculating electron, and so on and so forth. If you're having if you need in need of any help, you can just type your message in the comment section, and I will gladly go through it and reply in time. This brings us to the end of today's lesson. So in our next lesson, we are going to be dealing with what? Symbol, valency, and chemical formula. Those topics are quite simple, but I found out that these are where scientists are missing it out. Some people tell you chemistry is very hard, it's very hard. No, it's not very hard. It is the foundation. Foundation is the most key, is the most important thing. Most people doesn't have this for the foundation. If you have this foundation, you'll find chemistry quite simple. Thank you for your time, and thank you for being here with us this morning. Please do well by subscribing to our channel, and don't forget to on the notification button. See you next in our next class. Peace out.